Hi everyone, I'm Bridine Dempsey and I'm a current civil engineering student. In today's video I will be discussing safety factors, also known as the factor of safety. So what is a factor of safety? A factor of safety can be defined as the measure of how a product is overbuilt. Therefore, it should be determined in the early stages of a project. This is to acknowledge how a material or the components of a system will work. Therefore, a factor of safety will determine the lack of confidence in a project. So where should a factor of safety be applied? Factor of safety can be applied in either the design process, calculations, when determining the material strength, for the duty of the project, and also in the manufacturing quality. So why is it important to calculate safety factors? Well, as engineers, we have a responsibility to ensure that the final design of the project is safe and is not dangerous for a customer or a stakeholder to use. Therefore, how can we determine safety factors? Safety factors for a project or object can be determined through research and development. We can also draw on our own past experiences and using common sense to determine the safety factor, as well as we can consult with other professionals in the field to develop a further understanding and to draw on their opinions of safety factors. Safety factors for a project can also be determined through modelling the scenario in multiple ways. This is because testing and evaluating prototypes and models are important to identify and raise safety factor issues. Therefore, this can lead to modification to the original design. So how can we calculate the safety factor mathematically? The factor of safety can be achieved by dividing the ultimate capacity or actual breaking strength of the design over the normal working load. This calculation is to account for the imperfections in materials, the flaws in assembly, material degradation, and unexpected stresses that may apply on the design. So let's now consider safety factors in engineering practice for elements of a structure. Firstly, we'll have to develop the key aspects of the structural design analysis. So this will include converting physical situations into mathematical descriptions, understanding the results of the calculations, and also know when the mathematical model ceases to be valid. Therefore, the engineering calculations can determine the input information used to determine the factor of safety. Input information can include the size of the structural member or the process equipment components for the design load, material properties or performance criteria of the member. So here are some images of structures that their overall system performance has failed and the consequences of failure when a design or a project does not consider safety factors and the dangers of unsafe structures and practices opposed to stakeholders and customers. Therefore, an added factor of safety should be considered in our design when calculating the design load of the structural member to determine the upper boundary estimate of forces that may occur. So we consider design forces to be much higher than the normal load. This is to allow for unusual conditions that may occur. So for example, when we're designing a building, we know that we need a dead load and an alive load. Therefore, if you're designing a balcony for a building that would normally only hold 1 or 2 people, you'd use building codes to the design, assuming that what would happen to the balcony if it was crowded with lots of people. So material properties, when determining this factor of safety, calculations must cover the minimum value to meet the grade of safety standards, not the average value. You should also allow for material defects that may occur. Analyzing performance criteria of a structural element, this allows you to understand the requirements and the ultimate goal or function of the design. So for example, a performance criteria could include the rupture under short-term stresses. This can be a limitation of a design. Most designs are based around deflection, elastic stability, deformation under long-term loads, or fatigue under repeated cycle loading. So these are performance criteria that have to be considered to ensure that we are producing our best design. So where as engineers can we learn about the design considerations that affect safety factors? This information can be found in codes and standards. Examples of codes and standards include Australian Standards and Building Codes Australia. Overall, my closing points for this presentation are: many people think good engineering uses calculations to reduce the size and the strength of components to a minimum. However, experienced engineers have the responsibility to consider the overall system performance and the consequences of failure when designing a project or an object. Safety factors must be communicated clearly, precisely, and accurately to the project team throughout the entire design process. Thank you for listening, and I hope that I've been able to assist you in your learning of safety factors and that you may be able to apply this knowledge I've been able to provide you today in future engineering projects. Thank you.